What does a derivative really mean? A derivative tells us one thing, how fast something is changing at a single point. But what does that really mean on a graph? Imagine picking 2 points on this line. We can find the average rate of change between them. It's just the gradient of the line connecting the 2 points. How was the formula for the derivative derived? Let's say we are given the function f of x. Let's define two random points, p and z. Point P has coordinates x and f of x. F of x is the corresponding y value to the x value according to the given function. H represents the change in the x values, how much the x value has gone up by. So therefore, point Z has x coordinate x plus h and y coordinate f of x plus h. Since the gradient is equal to the derivative, we substitute into the gradient formula to get the formula for the derivative of any function. The gradient of the secant line shows the average rate of change between point Z and point P on the curve. As we make h smaller, meaning we move point P closer to point Z, the secant line starts to look more and more like a tangent line at point Z. When h becomes extremely small, the secant line becomes the tangent line, which touches the curve at exactly 1 point. At this stage, instead of finding an average, we find the exact gradient at point Z, which tells us how the function is changing at that point. This happens because we are taking the limit as h approaches 0, which tells us what value the gradient is getting closer to as point P moves as close as possible to point Z. This idea gives us a way to find the true gradient at any spot on a graph for a function that has just one variable, which is called a univariate function. Let's take a look at this function. First, we find the value of f of x plus h by substituting x plus h into our function. Then we plug this into the formula, group like terms, then factorize. We see that h cancels out, and then we can now find the limit by substituting 0, and our answer is our derivative. If we want the instantaneous rate of change at a point, we substitute the x value at that point, and the answer is our gradient at that point. The real mathematical definition of a derivative is the instantaneous rate of change of a function at a specific point. Derivatives appear everywhere. They describe how fast a car accelerates, how quickly temperature changes, and how the value of money shifts over time. I guess you could say, this video reached its limit. Subscribe for more quick math insights.